Hello student, welcome to digital learning platform. Today let us see about transport layer. As you all know that there are 7 layers in OSI model. The transport layer is the fourth layer in the OSI model. This layer takes the data from upper layer, then breaks it into smaller size segments and hand over to the lower layer for delivery. This layer is the first one which breaks the information data supplied by the application layer into smaller units called segments. This layer ensures that data must be received in the same sequence in which it was sent. The transport layer is responsible for end-to-end communication over a network which may or may not belong to the same subnet. A process on one host identifies its peer host on remote network by means of port numbers, and a process which is trying to communicate with its peer knows this in advance. For example, when a DNS client wants to communicate with remote DNS server, it always requests on port number 53. Transport layer has two major protocols. They are TCP and UDP. TCP is nothing but Transmission Control Protocol. It provides reliable communication between two hosts. There is a connection between two hosts, connection oriented. And second one is User Datagram Protocol. It provides unreliable communication between two hosts, connectionless services. Transmission Control Protocol. The Transmission Control Protocol or TCP is one of the most important protocols of Internet Protocol suite. TCP is widely used protocol for data communication in communication networks such as Internet. TCP header. The length of the TCP header can be of minimum 20 bytes and up to 60 bytes. So there are different fields in TCP header: source port, destination port, sequence number, acknowledgement number, data offset, reserve field, flag field, window size, checksum, urgent pointer and options. Let us see one by one. First one is source port. So it is of 16 bit. It identifies source port of the application process on the sending device. Next one is destination port. It is also of 16 bits. It identifies destination port of the application process on the receiving device. Next, sequence number is of 32 bits. Sequence number of data bytes of a segment in a session. Acknowledgement number. When acknowledgement flag is set, this number contains the next sequence number of the data byte expected and works as acknowledgement of the previous data received. Next field is data offset. This field implies both the size of the TCP header and the offset of the data in current packet in the whole TCP segment. Reserved field, reserved for future use, and all are set 0 by default. Flag field contains different set of flags. They are URG, ACK, PSH, RST, SYN, FIN. URG indicates that urgent pointer field has significant data and that should be processed. ACK indicates that acknowledgement field has significant. If ACK is clear to 0, it indicates that packet does not contain any acknowledgement. Next, PSH. When this flag is set, it is a request to the receiving station to push data to the receiving application without buffering it. RST, reset flag. It has some following features. It is used to refuse an incoming connection. It is used to reject a segment. It is used to restart a connection. SYN, this flag is used to set up a connection between hosts. And the last flag is FIN. This flag is used to release a connection and no more data is exchanged thereafter. Next field is window size. This field is used for flow control between two stations and indicates the amount of buffer the receiver has allocated for a segment. That is how much data is receiver is expecting. Field is checksum field. This field contains the checksum of header, data and pseudo header. Pointer, it points to the urgent data byte if URG flag is set to 1. And the last field is option field. It facilitates additional options which are not covered by the regular header. Option field is always described in 32-bit words. If this field contains data less than 32-bit, padding is used to cover the remaining bits to reach 32-bit boundary. And the next topic is TCP Connection Management. TCP communication works in client-server model, where the client initiates the connection and the server either accepts or rejects it. Three-way handshaking is used for connection management. In this figure, you can see client initiates the connection and sends the segment with sequence number. Server acknowledges it back with its own sequence number and acknowledgement of client segment, which is one more than client sequence number. Client, after receiving acknowledgement of its segment, sends an acknowledgement of server's response. Protocol. The UDP is simplest transport layer communication protocol available in the TCP IP suite. It involves minimum amount of communication mechanism. UDP is said to be an unreliable transport protocol, but it uses IP services which provides best effort delivery mechanism. In UDP, the receiver does not generate an acknowledgement of packet received, and in turn, the sender does not wait for any acknowledgement of packet sent. UDP header contains four main parameters: source port, destination port, length, and checksum. First one is source port. This 16 bits information is used to identify the source port of the packets. Destination port. This 16-bit information is used to identify application level service on destination machine. Next one is length field. Length field specifies the entire length of UDP packet including header. It is 16 bits field and minimum value is 8 byte, that is the size of UDP header itself. Next one is checksum. This field stores the checksum value generated by the sender before sending. IPv4 has this field as optional, so when checksum field does not contain any value, it is made 0 and all its bits are set to 0.